All right, we are going to go on to a new section called Conditional Statements. We're learning about logic and reasoning. We'll do some vocabulary here. A conditional statement is a statement written in if-then format. So any statement that's like a hypothesis, then a conclusion. So a conditional statement has two parts. It has hypothesis, which is the if part, and a conclusion after the then part of the statement. So if X, then Y. You can see it moving with this arrow here. If you have no more than two absences and a B average, then you can be exempt from your final. So this part here after the if, this is your hypothesis, and then this is your conclusion. So hypothesis and conclusion. If something happens, then another thing happens, right? So moving down here, sometimes statements are not written in conditional if-then format and need to be rewritten. So like this one, the car with poor brakes is a menace on the highway. So our subject, if, what happens first? Think of what happens first. And then the then is the consequence of that, or what happens next. So subject of the sentence, if a car has poor brakes, then, right? So then what happens if a car has poor brakes? Then it's a menace on the highway. So if then. So if a car has poor brakes, write it again, then it's a menace on the highway. What a funny word, menace. All right, here's our converse. Converse is the statement formed by flipping the hypothesis and conclusion, by flipping. So if it's raining, then take an umbrella. Let me move this up a little bit so you can read it. If it's raining, then take an umbrella. Here's our hypothesis. Our hypothesis is the if it's raining. And the conclusion is take an umbrella. The converse is flipped of that statement, is the if and then stay in the same spot, but the conclusion becomes the hypothesis. So if you take an umbrella, then it's raining. It is raining. So sometimes that's not necessarily true, right? Just because you take an umbrella doesn't mean it's going to be raining. So determining truth, a statement is considered to be true when no counterexample can be provided to disprove the statement. So a counterexample is a statement, an example that proves the statement is false. False. So a counterexample can be a statement or a diagram. So if an angle has a measure of 120, then it's an obtuse angle. Is that statement true or false? Well, can we think of a counterexample that has a measure of greater than 120? That's still an obtuse. Well, let me think about this. What about 180 degrees? That's not an obtuse angle, that's a straight angle. So this is not necessarily true. If an angle is obtuse, then it has a measure of 120. Well, that is true. There's not a counterexample. Oh, nope, it's false, because if an angle is an obtuse, then it has, what about something that's 150 degrees? That's still obtuse, right? But it doesn't have a measure of 120. So we found a counterexample for both of those. All right, let's look at this. The inverse statement is formed by nodding. I'm going to call it nodding, or we can also call it negating both the hypothesis and conclusion of a conditional statement. So here's an example. We'll go back to our raining an umbrella. If it is raining, then take an umbrella. If your hypothesis, it is raining, take an umbrella is the conclusion. Umbrella. So the inverse is negating that statement. So I'm going to say, if it is not raining, then do not take an umbrella. So you're adding this not to the statement, negating it. So conditional statement, if school is in session, then it is a weekday. The inverse of that, let's see if that's true or false. If school is in session, then it's, so if, the inverse statement is if school is not in session, then it's not a weekday. So if school is not in session, then it is not a weekday. Is that true? If school is not in session, then it's not a weekday. Well, could it be not in session and a weekday? Well, we just had a holiday, right? So what about when we have a holiday on a Monday, right? Then it would be false. All these are false. Conditional statement. If you pass the STAR test, then you will graduate. If you don't pass the STAR test, then you won't graduate. Well, that one is true. If you don't pass, then you won't graduate. Can you think of a time when you don't pass the STAR test and you still graduate? Nope. No counterexample. Oh, goodness, excuse me. Our contrapositive statement is formed by flipping and, there's not enough room, and nodding both the hypothesis and conclusion of the conditional statement. So if not Y, then not X. So here's our conditional. If you run a red light, then you are breaking the traffic law. Converse is flipping. If you break the law, then you run a red light. And your contrapositive of that is if you don't break the law, then you don't run a red light. So let's see if we can find a counterexample of this. If you break the law, then you run a red light. Well, I can think of plenty of other ways to break the law by not running a red light, right? So that one's false. If you don't break the law, then you don't run a red light. If you don't break the law, then well, that is true. That's true. So students must pass Algebra 1 to graduate high school. So your conditional, let's change it to an if-then statement, okay? Students must pass algebra to graduate high school. If you pass algebra, oh, nope. Let's write it differently. Because we gotta, is it graduate first? If you graduate, then you pass Algebra 1. Yeah, if you graduate, then you pass Algebra 1. All right, your goal is to write the converse, the inverse, and contrapositive of these statements. And we'll do those together in class.